Hello there. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. Are you ready to take off today? So, this is the first lesson of weight and balance of the aircraft. Okay, I'm your commander today. So, also the load sitter in charge to teach you and also the lecturer. So, we start the scenery, the itinerary today, with the routing of the load sheet theory, the lesson of the load sheet theory. So I have to check first whether the system is okay now. Okay, so this is the load sheet theory here. You can see the objective of the lesson is, at the end of this lesson, you will know how an aircraft flies, Now about the forces that act an aircraft in flight. Now about the different speeds of an aircraft at takeoff. And now about the aircraft takeoff performance. So the topic index for today is how the aircraft flies, the four forces, speed at takeoff, and aircraft takeoff performance. So this is the gonna lesson. We use this as computer-based training, when I was work there. This is in order to fly an aircraft must be provided with a lifting force. A lifting force equal to or greater than its own weight. The air surrounding the aircraft provides this lifting force. Okay, so this is to demonstrate the simple experiment shown here. A piece of narrow paper is held to the top of the lower lid, you can see, and an airflow is created by blowing. The movement and airflow across the top of the paper cause it to rise. Okay, this can further be demonstrated with a piece of cardboard. Cardboard helps an angle and pass quickly through the air. The airflow underneath creates a lifting forces that pushes the cardboard upwards. So this is the direction of travel when the pass. So this is how the aircraft can fly. And then when the cart stops moving forward, the airflow also stops. The lifting force stops and the cart stops rising. And it is airflow that we consider when studying the theory of flight. So this is the airflow that we consider when flying study of a flight. You can see direction of forces here. And aircraft wing, you can see here, is made of two surfaces, each with a different curve or camber. A curved surface produces a more effective lift. So this curved surface produces a more effective lift than a flat surface. Lifting force. This is the lifting force. As the wing moves through the air, the airflow splits into two. This is on the top of the wing increase in speed, while the air passing below the wing decreases in speed. So this is due to the curve of the wing. The air passing underneath increase in pressure and pushes upwards, while the air passing over the wing decrease in pressure and creates a suction effect. So this is the lifting force. Yeah, you can see. The combination of these two forces produce a lifting force. So, for example, this is the equation. As an aircraft flies, the wing split the air into two. What happens to the air passing over the top of the wing? So, where is the correct answer? Oh, of course, increase in speed, yeah. If air passing over the top of the wing will increase in speed and decrease in pressure. So this is the correct answer on the right-hand side. So the air increase in speed and decrease in pressure as it passes over the top of the wing, which produce a lifting force. Okay. Okay, we go on the next question. What happens to the air as it passes below the wing? Of course, decrease in speeds and increase in pressure. This one. The left hand side is the correct one. And now we have seen how the shape of the aircraft wing use the air to create lift. The angle at which the wing meets the airflow is known as the angle of attack. Angle of attack here is 10 degrees. And this is lift increase as the angle of attack increase. And however, if the angle of the attack is too great, a wing stall occurs. A wing stall will occur if angle of attack is too great. Let's say this is 50 degrees, then we'll create a wing stall. This is when the airflow over the surface becomes turbulent and a loss of lift occurs. So loss of lift occurs. And this is the wing flaps of Boeing 747 and A330. The location of wing flaps, you can see. So the aircraft have the ability to change the angle of attack by changing the camber or curve of the wing using the wing flaps. These wing flaps manage the angle of the aircraft during flight as well as enabling the pilot to increase lift when required. Although aircraft vary from type to type, the location of these wing flaps is common on most. So this is the location of wing flaps. Pilots use wing flaps for several flight operations. For example, during takeoff, the wing flaps are usually extended to half flap position to obtain the additional lift required. In this position, the wing flap produce more lift because of the increase in camber. However, if the wing flaps are extended beyond the halfway position, they act more like brakes than lifting device. You can see here, when halfway position, they act more like brakes than lifting devices. Although not suitable for takeoff, of the braking effect of the wing flap at full flap position is very advantageous for landing. It enables the pilot to land the aircraft at much steeper angle of descent without increasing airspeed. So this is how the aircraft has been, aircraft manufacturers build stability into modern aircraft design to ensure that they remain level in flight. However, passenger and cargo load distribution can result in aircraft having a nose up like this or nose down tendency like this. Because of this nose up or nose down tendency, aircraft are fitted with the horizontal stabilizer. This is horizontal, where the horizontal stabilizer is. The horizontal stabilizer can be adjusted by the pilot to correct any imbalance. The load controller is responsible for calculating the horizontal stabilizer setting or step trim. He then passes this information to the pilot. You will learn how to do this calculation later in the course.